Theme: life of a star from its birth to its extinction. The life of a star varies greatly, depending on its mass, and can range from millions to hundreds of billions of years. Below, we will explain in detail the life cycle of a star. From its birth to its extinction. 1. Birth: from interstellar gas to protostar. Stars are formed from molecular clouds, made of interstellar gas and dust. Contraction of molecular clouds. Gravity begins to contract in the dense parts of the gas cloud. At this time, external supernova explosions and galactic collisions can trigger this formation of protostars. The gas contracts and heats the center, and in about tens of thousands of years, a protostar is born. At this stage, nuclear fusion has not yet begun, but gravitational energy is converted into thermal energy, and it appears to shine. 2. Main sequence stage: energy supply by nuclear fusion. The main sequence star is the stage in which a star spends most of its life. Hydrogen nuclear fusion. Nuclear fusion reactions begin, and hydrogen is converted into helium in the center of the star. This reaction is the source of the star's light and heat. Lifespan. The lifespan of the main sequence depends on the mass of the star. Massive stars e.g., stars with a mass of 10 times or more lifespan. Approximately several million years. Small mass stars e.g., the Sun lifespan approximately 10 billion years. Red dwarfs: low mass stars. Lifespan over several hundred billion years. 3. Evolution changes after hydrogen depletion. When hydrogen is depleted, nuclear fusion in the center of the star stops, and the structure changes. Evolution to a red giant or supergiant. Nuclear fusion moves to the outer layers and the star expands. Stars the size of the Sun become red giants, and massive stars become red supergiants. Helium fusion. The fuel for nuclear fusion switches to helium, which produces carbon and oxygen. In even heavier stars, elements from carbon to iron are produced. 4. Extinction final stage. The final appearance of the star varies depending on its mass. One stars the size of the Sun: medium mass stars. Planetary nebulae. The outer layers are expelled, forming beautiful gas clouds. White dwarfs. The center contracts and becomes a white dwarf. White dwarfs do not undergo nuclear fusion, but simply cool down. 2. Massive stars. Supernova explosions. When iron is produced in the center, nuclear fusion stops and gravitational collapse occurs. This results in a spectacular supernova explosion. Neutron stars are black holes. After the explosion, a neutron star or a black hole is formed, depending on the mass of the core left behind. 3. Low mass stars such as red dwarfs. Nuclear fusion proceeds slowly, so they have a very long lifespan. It is believed that they eventually become white dwarfs. Factors that affect the lifespan of a star. 1. Mass. The mass of a star has the greatest impact on its lifespan. The greater the mass, the faster nuclear fusion proceeds, and the shorter the lifespan. 2. Metallicity proportion of heavy elements. Stars with a high metallicity tend to have a slower progression of nuclear fusion and a longer lifespan. Star lifespan and its impact on the universe. Throughout its lifespan, stars supply energy and matter to the universe. Supply of elements. Heavy elements such as carbon, oxygen, and iron produced inside. Stars are released into the universe by supernova explosions and stellar winds. Formation of the next generation of stars and planets. The released gas and dust gather together to form new stars and planets. The magnificent process from the birth to the extinction of stars is deeply connected to the evolution of the universe and the origin of life. This cycle can be said to symbolize the life of the universe itself.